Jim Anspach. Great to have you. Thanks for taking the time to sit down with me on It's Paint on the Boots is the name of the podcast.
Paint on the Boots, I like it.
Yeah, not my idea. That's Grant Dubois with ITC. So
I've had a lot of paint on my boots and other places.
Yeah.
Roof of the car.
Technically, it's Paint on the Boots Maximum Overspray. That's my edition. So there's a little spray can that comes out. We'll probably put the thing up right now. Where are we? What are we talking about? So 2025, this is what, the 25th anniversary of the Construction Institute for the ASCE. It's amazing.
Yes, it is. Before the Construction Institute, it was called Management Group F.
Oh, F. What made it F?
I don't know. That was before my time.
They went down the gamut. That's a lot of management groups.
That's right. That's right.
Cool. So again, thank you so much for sitting down with you. I think you and I crossed paths the first time, 2010-ish.
Sounds. I would have no reason to refute that.
Yeah, there was a government project going on. I think there was 8 different technologies that you were involved with.
Oh yeah,
UIT.
The Strategic Highway Research Program. The RO1B or C, whichever it was looking at different types of geophysical equipment that could maybe be combined onto a single platform to reduce the number of scans and amount of time needed at that time. And it's interesting in that the English component of that had a program called Mapping the Underworld going at the same time with the same purpose. So
Very cool.
we had both continents working on that issue, and it doesn't. Here it is, 2025, and we're just now arriving at a potential solution. But we needed to get cloud storage and data processors faster and things like that before it would become viable. So we tried a lot of things, and we could put multiple units on a single platform and push it, and we could figure out where those sensors were in space and combine the data. But it took 15 years of catching up to get to the point where maybe we have something that in the next couple years might be economically feasible to use.
Interesting. Yeah, can't wait to see the results of that. That's only been, how many years in the making, right?
Exactly.
It's amazing what technology can do as far as processing. We were talking about that yesterday, just with the iPad. I think it was 20% increase from one version to the next, and then from that version to the latest chip is like a 60% increase.
Yeah.
Which enables certain GPR companies to do post-processing now on the fly. Something you would have to do in the past, have a person in the field, take that data card out, go back to the office, import the data, have somebody else take a look at it. It could have a week before you see the data you can see in real time now, which is remarkable.
I remember one of the biggest issues in those days was knowing and remembering when to stop collecting in one file and start a new file.
Right, because you run out of space.
You'd run out of space and you'd crash your computer processing power.
Yeah, I'm not going to talk about microfiche. That's another thing, records and stuff. So let's get to the nitty gritty here. I know we're limited on time, but what I would really like to know is, how did you get into the industry? Tell me a little bit about yourself.
It wasn't a planned career path by any sort of the imagination. I always liked being outdoors. I had a scout master who, at the time, I did not know this, but he was a fairly well-renowned geophysicist. And as a kid, you don't really know what the parents of the other kids are.
Right.
You just, they're there with you when you're outside, and he seemed to be able to pick up a rock and explain it, and a little bit of how it interacts with what we are as humans and our society and building it. And I thought, well, that's pretty neat. I like to be outside. I like to hike around. I like to explore the world. maybe I should be a geologist. It combines all of the different sciences and chemistry and physics and biology and large time scales and maybe even a little bit of spiritual philosophy going in there. So I graduated from Penn State in the geologic sciences, and I had a choice. Go to the North Sea on a platform, go further in grad school, or go to the Middle East. And none of those options in 1977 were very good.
I don't think the North Sea is very good today. The Middle East could be close second, right?
Yeah, that's right. And so I was hunting around for what can I do with my life at this point. And I found a position with a company called Heath Consultants. Heath Consultants had contracts with natural gas companies and water companies to find leaks. That was their specialty, is find the leaks. But it became really clear to me early on that if you want to find a leak, you have to know where the pipe is, where it's leaking out of, because it doesn't always end up, the product, right at that pipe.
Right.
And so Heath Consultants also had a technical arm and an education arm about here's how we are going to use line locating equipment and corrosion engineering, fault finding equipment and other things to make sure that these pipes maintain their integrity and things like that. But we were really, even back in 1978, treating it as if it were witchcraft. And nobody was doing it other than the utility owners themselves. So there weren't anything like a contract locator or a private locator. There was only the utility owners, and they called it witching. Mm-hmm. And in fact, if you look at the old Fisher M scopes at that time, you'll see that they're actually called witching. Electronic witcher.
Yeah, I've seen that.
And so I started thinking about this, saying, well, this is not witchcraft. It's not an art, which is what everybody said. It was an art. I said, this is a science. This is an inexact science. There's a lot of uncertainty, but there are scientific principles about why this works. And if we knew more about the utilities and the geophysical pieces of equipment that we were using to find them, mm-hmm. maybe we could do a better job. So I kind of stumbled into a career at Heath Consultants, educating utility owners on this is why your pipe and cable locator works, and this is how you can use it more effectively. But about that time, the Metrotech 810 came out, and I still have Metrotech number 1. 810
nice.
number 1.
I have an 810 and an 850, but you have number 1.
I have number 1.
That's amazing. I got to figure out what my numbers mine are. I'll let you know when I get back.
So it has tin foil in there, and soldering connections and all of that.
The coiled cable.
Yeah. But I was giving classes around the country to utility owners. So I'd go to like Washington, D.C. and set up a class and bring in utility owners who were interested, and I'd show them this equipment. But the Metrotech 810 had just come out, and the chief relocation engineer for Washington Gas Light attended my class. And he had just bought this Metrotech 810, and about a week after the class, he said, Jim, I don't think it works. I can't find this utility, and he had just started a company called So Deep Inc., where he was using vacuum excavators to find his gas line or other utilities and tell contractors how deep something was, because that was the big problem still, right. in a way, back in the 1970s, where contractors would say, well, I'm building this project and your gas line's in the way. Can you tell me at least how deep it is or get it out of the way? And he was thinking, well, why can't we do this as the gas company? And the reason is records are inexact. We didn't have surveyors making records back then. We paced things off and made our best guesses as to where something was. But regardless, we decided to go into business together, and it was clear that if you're going to use a vacuum excavator in an 8-inch by 8-inch hole, you have to be really good and precise with using your geophysical equipment. Otherwise, you'll miss that utility and you don't make any money. So we went into business and developed the concepts of subsurface utility engineering, and so it wasn't a conscious career choice. It was a series of take a step forward, evaluate, see what's going on, take another step forward, and here it is, 2025. I've made a lot of steps since then.
Nice. Very cool. That's a great story. I've heard of So Deep. I didn't realize you were involved with So Deep. I knew there was some sort of relationship, but that's pretty cool.
Yeah.
Nice. So I think that answers my next question, but maybe you can expand on that. So was there a specific catalyst or sequence of events that led you to create 3802 originally?
Yeah. So 3802 came about. It's a long story, but I'm going to make it short. Came about when Paul Scott, who was the chief utility engineer for the Federal Highway Administration, he and I were teaching a class at the University of Alabama. And the head of the engineering school down there was very interested in what we were talking about. We were talking about this concept of subsurface utility engineering. We had that name, but we didn't have things, we had the quality levels, but we weren't really using them on deliverables yet. We were using them as a construct of, here's a quality assurance type program.
And when was this in the timeline of?
Yeah, this was about 1995, give or take. And so in 1995, we were giving this class, and we were having dinner at Dan's house afterwards, and I said, I have a couple problems in my industry. I've got some competitors who aren't doing nearly as rigorous of an engineering process as I am, but yet this industry is growing, this practice is growing, and they want to have an association. And the reason they want an association is to dumb everything down so that they are on a more equal playing field as the industry grows. And I said, I don't want that. I want excellence. I don't want mediocrity.
Are you willing to say what association that was?
Well, there wasn't an association yet.
Gotcha.
It was an individual in a particular company.
Gotcha.
Who wasn't able to compete as well in the engineering world because they came from a contractor's background.
Gotcha.
And Dan said, we've got another problem in the civil engineering world, in that engineers are putting the disclaimer on plans saying, I'm not responsible for utilities, it's the contractors at the time of construction, and the courts are no longer recognizing that as a valid disclaimer because the engineers are supposed to protect the health, safety, and welfare of the public, and there are ways that they can do better at finding these utilities up front and getting them out of the way during construction so that there isn't a potential for a damage. And he said it would be great to take your concept of subsurface utility engineering and these quality levels and create an ASCE standard. And that might be better than an association of subsurface utility engineering firms because we are the largest engineering organization in the world with a lot of clout. And I started thinking about that, and it seemed like a really good idea. So he got me in touch with two people. One was Dr. Tom Isley, who I knew from before, and Tom was running the management group F of ASCE, which was right then transitioning to be the Construction Institute. And and Dr. Ahmad Habibian, who is with Camp Dresser McKee now. Ahmad was in charge of the ASCE Codes and Standards program at that point. So I put a proposal together to create a standard that would standardize the way we address uncertainty of utility depictions on planes. Some are more certain than others. And if that's what engineers do, is they understand the uncertainties and then design safely around those uncertainties. And that was accepted, and we put together a committee and worked on it feverishly, and finally got that put together and published in 2002. Actually, January of 2003, but we say it was 2002.
Nice. Yeah, that really changed the game. It really did.
Yeah.
Globally, there's a lot of different countries. Like, what countries off the top of your head that you're aware of wrote standards around that?
Yeah, well, we started with Australia, and then went to England, and then went to Ecuador, and then went to Malaysia, and then went to France and Italy, maybe Canada. Maybe that's it.
Nice. I knew there was a short list, but it's longer than I remembered. That's awesome.
Yeah, there was a lot of international travel involved.
Yeah, sounds awful. I love travel. Nice. So my next question is fast forward 20 years. So what was the biggest challenging in creating the 2022 standard?
So in my computer, I have folders marked ASCE 3811, ASCE 3817. There's about four or five different folders there where I thought I was getting to the point where, okay, we're ready, we're going to get ready to ballot this and get it republished. But the problem was that the technology and the practice both kept evolving so quickly that by the time I would get it bundled together and say, this is where we're at, we were already behind the curve.
Wow.
And it just kept going and going, and you kind of have to think ahead. Okay, when are we going to get a little bit of a stop or a pause in technology or practice so that we can catch up to that? And it really, I think that pause and hiccup came because of COVID, and that gave everybody a little bit of time and technology. We were still, in fact, probably working more on those advancements, but they weren't being pushed out into practice yet because we didn't have the face-to-face interaction.
Wow.
So we were finally able to catch up.
So the QR code and ASCE 3822 we can thank for COVID, pretty much. Nobody really
that and Teams and Zoom and no more newspapers and all of that kind of stuff.
Yeah, that's pretty remarkable. I didn't realize, but it makes perfect sense.
Yeah,
very cool. So here's a curveball. So what's a commonly held belief that you wish to dispel about your work?
Yeah, so I think what has been, for me, getting the most traction lately is giving a little history of where the term subsurface utility engineering came from. Because I think the biggest misconception out there is it's mapping utilities with a vac truck and a series of geophysical equipment, and that's it. That's all there is to it. Right? And in reality, the term subsurface utility engineering came about as SODEEP evolved a bunch of different services. Originally we did what we call designating, which was finding all the utilities within a corridor for a major CATV build in Washington, D.C. So it didn't matter what utility was in that Virginia Power right-of-way, we were responsible to find it and mark it and make sure it didn't get hit during construction. Where they were using road bores, we then would vacuum excavate it, leave that hole open. And this was before trenchless technology, before we had things like HDD.
Mm-hmm.
But we were leaving that open, and then they were just pounding pneumatic holes through the ground and hope to get there. But then we started working for the DOT on their projects and added the survey component because we wanted to get the information on the plans early. And then we realized, gee, we've got this great information, but somebody has to tell the engineers what to do with it because they weren't used to getting it. And there was no thing yet called utility coordination back then. It was utility field inspection. Generally, you deal with utilities at about the 90% design phase and say, okay, now we're done with the design. Where are you, utility owners? Let's see if we can deal with you.
Right.
So we thought, okay, we need to get this information on the plans, which means we need to survey it. So we did that. And then it was communicating all of those issues not only with the designers, but with the utility owners to try to figure out amongst them, this is who's going to deal with it and how we're going to deal with it. We can change a design, we can't change a design. You can be involved before construction starts to move your utility, or we have to do it in conjunction with it. This is how much you're going to get paid, and this is what you can salvage, all of that. So we added that function in along with condition assessment, which I was able to bring from my Heath Consultants days. What kind of shape, are there any leaks? What kind of shape is a pipe in? Is it corroded? Is it not? Let's put that in the mix. And then we had to get insurance for these services. And the insurance company said, well, nobody's ever done this. You're not really a design firm, you're not really a contractor. How are we going to insure this? And so we figured out a mechanism to actually pay an insurance executive to be embedded in our company for 3 months, seeing what we did. And they said, this is great, we can insure it, but what are we going to call it? We can't call it design, we can't call it survey, we can't call it locating. It's a mix of all of this, and we came up with the term subsurface utility engineering. That was all of those services, and we always intended it to be all of those services. A turnkey, we will deal as a utility engineer with the issues of utilities on infrastructure projects. Unfortunately, people got so enamored of the vacuum truck and a pipe and cable locator that all of the competitors that spring up as you create a market and demand said, well, this is really what SUE is. It sucked the dirt out of the ground and put it on the plans. And they're really missing the engineering component of that. And I want it back. So that is my biggest regret, was that I allowed that to happen, and I allowed it to go on too long, and it's challenging to bring it back to that point. But 3822 went a long way towards that, and 3827, or whenever the next edition gets published, will continue that journey.
Nice, yeah. It's interesting. So people think that just because they're doing things according to O2, that it's magically that quality level, right? So what's the deciding factor that actually makes something QLA, QLB, QLC, QLD? Like, what has to happen in the chain in order to have it not just be a locator or a vacuum truck?
Yeah. So here's a little tidbit that is so important to understand, and yet nobody understands it. And that is, we didn't have quality levels when we started. What we tried to do was find everything we could with geophysics as step number one. And where we had information, because we could see some structures, or we saw a light on in a house, but we didn't see an electric line and we couldn't find it with geophysics, or we had a record from the utility owner or somewhere else that said, yeah, there's something there, and we couldn't find it. We needed to show that on the plans, but yet it wasn't the same as being designated, where we were going to know that we could excavate it within an 8-inch by 8-inch window and find it. We were uncertain about that. So we came up with these concepts of quality levels to address the different ways we ended up getting information on the plans. But we always started with the geophysical search. Then what happened was the FHWA said, we love this idea, we're going to promote it, but you know what? All of these state DOTs have their own existing project development schema out there, and they all have engineers that will call the utility owners and get records, and they've got their topo surveyors, and they do of that. Well, that's quality level D and quality level C, but in reality it isn't. We start with the geophysics, and what can't be achieved with geophysics we call quality level C or D. So what has happened is we have a lot of people saying, well, we need a quality level D map. Well, 3 centuries ago we did the same thing. That's not new. That is not, in my mind, what subsurface utility engineering was. That's ancient practice. And we just call it something different now that probably shouldn't be quality level D. So what makes it a quality level, in my opinion, is the attempt to use the appropriate investigative technique and technology to get an answer and then resolve all the other information that you have available at that point if it doesn't fit that answer. And it has to be stamped by a registered professional. Mostly engineers around the country, but there's a few states that are wacky that say, well, this is a survey function, even though surveyors don't necessarily have to have any physics classes or electrical engineering or understanding of how utilities are put together or information on how geophysics works. All they can do is say, I surveyed a paint mark and my survey is correct.
Yeah.
Well, that's not what we are doing, and they're sadly mistaken at their state board level, and we need to fix that.
Yeah, unfortunately, I've seen that where it says map. It's automatically under care of a surveyor.
Well,
yeah.
And so I know you've been asking the questions, but I'm going to go offline here with you a little bit. One of the problems has always been we termed what we were doing subsurface utility engineering, and then there was a new term introduced, subsurface utility mapping, right? And if you look at Copilot on AI or some other programming, you say, what's the definition of subsurface utility mapping? It says subsurface utility mapping, also known as subsurface utility engineering, is this, and we know that it's a little different. And so for the first time, we have now formally defined ASCE in ASCE the difference between subsurface utility engineering and subsurface utility mapping, which is basically the comprehensiveness and the rigor and the stamp that goes with subsurface utility engineering versus subsurface utility mapping, which could be very close to subsurface utility engineering, or it could be vastly different.
Right.
It could be vastly different.
Right, so, and that defeats the purpose of having standards.
That's right.
Right.
That's
so
right.
That makes sense.
So I'm excited about getting those new definitions out and understood by people.
Yeah, I think that's important. Like, I'm going to just let that hang, but I've seen a lot of articles on LinkedIn lately trying to dispel the myth between SUE and SUM. We live in an acronym-driven industry. But you're right, there's a lot of wishy-washy back and forth. Maybe people don't fully understand the intent, and I think that's important to differentiate the two.
Now, my biggest pet peeve
That's another one.
In the subsurface utility engineering world is marking. So we are not in the damage prevention business. We do not get rid of the mandatory response by utility owners or their contract locators to put a mark on the ground so that there is a statutory point the finger at who's responsible for the repair. We are working in the planning and design phase to avoid utility conflicts during design and during construction, but not damage prevention. And so originally, when we started our work, we realized that our marks in the ground that we were going to subsequently survey could not look the same as a utility owner's mark, or people would get confused. Contractors would get confused. Utility owners, gee, did we mark that or didn't we? It looks like we did. I guess I won't go.
I've been chased down the street by a gas utility worker in Peoria, Illinois for about 3 blocks because I didn't know any better back then. Doing private locating for an engineer, right, who were, I'm assuming, doing SU work, right, for a pretty big project, 8 square city blocks, and it was Adam responsible for doing this work.
Yeah.
And that's when I was like, all right, pink it is.
Well, so originally we thought, okay, what if we had an invisible paint that you had to put on special glasses and you could see it? That would be ideal because we don't want any paint marks out there if we can avoid it. But there was no such thing as invisible paint back then. I still don't think there is. I've talked to paint manufacturers. They can't seem to come up with it. So instead, we came up with a marking system that was very unique. It was a dot with 2 very short flags on either side in the correct color so that we could track the utilities and know how this dot connects to that dot to that dot. And we could actually even make the dot a different color and the flag's different color. When you have 20 different electric lines, you've got to differentiate maybe all 20. And so there's a lot of variations. You can't make them all red.
Right.
You just don't know how they cross over each other. So you could do that. But what happened was, as subsurface utility engineering grew and as contract locating grew kind of in concert with that, the field people would swap back and forth, and people didn't understand why we were doing what we were doing. So what happened was, increasingly, the damage prevention marks were identical to the designating marks by the SU firms. And in fact, you'll see a lot of people dot things out and put little flags. Well, they probably came from the SU industry and went to contract locating. The contract locators coming back have these big paint marks.
Right. It's interesting. It's actually defined as a dot isn't a mark, right? That's just the locator sniffing it out. A mark is defined as being 12 inches long and 1 inch wide.
Exactly.
With the appropriate 3 things: the facility owner, the size, and the material.
Yeah.
That's a mark.
In the appropriate color.
In the appropriate color. Yeah.
So what happened was, we went to start a SU program in Arizona in, I'm going to guess it was 1991. I got to Arizona, new state, and the gas company said, you cannot mark your gas lines in yellow. You need to do something else. So we went to APWA and we said, what can we do? And they said, well, let's come up with a new color. Surveyors have been asking for a color too, to identify where the project control is. They don't want to use colors that look like a utility. They want something that identifies it as a survey mark. You are marking for survey purposes, so why don't you just use pink? Now, that creates problems in a congested area because there's a lot of pink out there and it gets confusing. But, okay, so in Arizona, we started using pink for our subsurface utility engineering. And right now, there's probably half the states that say we want you to use pink and the other half that says we want you to use APWA color code. However, just 2 years ago in Arizona, the Arizona Corporation Commission said, we no longer want the SU firms to use pink because the surveyors are complaining, and it's not the correct color for the APWA color code. And I said, well, you're the ones who made us use pink in the first place. But, that was 30-some years ago,
right.
And it's different people. And so now they started fining the SU firms $500 for every time they used pink.
Wow.
Now, the caveat was that the Corporation Commission said you can't use pink. You must use the APWA color code, but you can only use it if you get the permission of the utility owner to use it. And so a lot of the utility owners, especially telecom, said, well, you can't use orange. So what are you supposed to do? You just say, well, we can't do our work. Sorry, citizen, you'll blow your house up. It's not our fault.
Wow.
That's ridiculous. So right now, I have an effort going at APWA to create a new color, silver or gold, which nobody likes. I don't like it because when it decays over time, it's going to look like white,
right,
or it's going to look like yellow, and we still haven't solved the problem. But what I really want to do is get a different code rather than 8 inches by 1 inch, and say you're going to put a dot, you're going to put 2 little flags on it. It doesn't matter what color it is. But I cannot get APWA to move on the concept of a different marking symbology, I guess, because of some historically intransient people within APWA that says no.
Another thing we used to do was a pink mark with a colored dot in the center, or a pink dot and a colored dot, keeping it simple, minimizing the amount of paint you're using.
Well, the Arizona Corporation Commission would fine you twice then.
Yeah, that's nuts. Wow.
So anyway, so my pet peeve is, again, something I let get out of control and didn't rein it in nationwide fast enough, and now it's a problem. And we don't know if, and in fact, my pet peeve as I started this off is I go on LinkedIn and I see these huge paint marks on the ground, and somebody who says, look at what I did. I'm such a great soup provider. I made this really big paint mark. I'm thinking, no. You just proved to me that you're not the great soup provider. You don't know what the F you're doing out there. And that's my pet peeve.
Yeah, I know what you're talking about, and I've decided not to chime in on those types of posts.
Exactly. You don't win if you say anything, but
yeah.
Hopefully they'll listen and get the idea here.
Yeah, well, good luck with the paint color issue. I don't know what you're going to do to overcome that.
Yeah, well, I've got some great people working on it. Monty Zimmerman from the city of Lenexa, Kansas, on the APWA Upper O Committee, and some other folks have really been bending over backwards to try to find a solution. So
nice.
Good.
Yeah, well, I can't wait to see what actually happens.
Yeah.
So all my pink paint, don't bring it to Arizona. I have a lot of it.
You can sell it to surveyors.
I just got a box. I got a flag shooter too. Have you ever seen the flag shooter? The thing's great.
Yeah.
They'll put your logo on there for free and everything. So I've got a box of 1,000 pink flags right now. Note to self:
okay,
keep them in California.
Yeah, well, not in Arizona, but just about anywhere else.
Right, interesting.
Get by with it.
Yeah, very cool. So you've already took the next one. Oh, so something you can change ties in with your pet peeve. Interesting. So you've been around for a while. Where do you see the industry going in the next 5 to 10 years?
Yeah, so something that is happening right now, 2 things I think that are of interest to me. The first is when I started the concept of multi-ticket response for contract locating, before anybody else was doing it, and the concept of subsurface utility engineering, it all came out of the same bunch of people, the same process, the same issues. And we decided, after doing tickets for Washington Gas Light and Fairfax County Water and Bell Telephone, we decided, given the constraints of having to mark something in 2 days, we're going to have damages. We can't get enough people there and control all of the contractors to say, well, you better not call in your ticket today because I don't have enough staff to do it. No, it doesn't work that way, right? So we knew that the system was set up to actually not have an effective damage prevention program. The state laws, they really need to change that. So we said, what's more important to us, what we think is more important in the long run is to maintain the name so deep and subsurface utility engineering not associated with the headline damage. Right. So therefore we will cleave our our services, and we will give up the damage prevention one call aspect to this, and we will march on with subsurface utility engineering, and we did that. However, they're coming back together again. I see them coming back together as technology changes, as we get more and more survey grade equipment that can capture marks on the ground and put them in a database and pull them out as needed. I see that coming together. So how that's going to play out and what the liabilities and do we degrade the geophysical aspects of subsurface utility engineering to meet the growing and better geophysical capabilities of private locators? I don't know. It'll be very interesting to see how that happens. But the second thing that is happening right now is we are moving to a 3D world. We've now got the cloud storage to do it. We've got the software to do it. So most state DOTs are using Open Roads Designer software, and you must populate the depth component. So all the SU firms now must always populate that depth component. And so we're populating that depth with a variety of methods. Check your symmetry of signal with a pipe and cable locator. Realize that it goes to the center of the signal, not the top. Use your multi-channel radar or single channel, but realize it goes to the top of the facility. Right. Use a sonde, but realize it goes somewhere inside the pipe, usually at the bottom. But you're going to have to rectify all of that with records and measure downs, and sometimes just your best judgment as to how to populate and draw that third dimension. Now, that third dimension will not have a quality level to it, because the quality levels really are meant for horizontal uncertainty, and the uncertainty of the depth is at least twice as bad because you only have one dimension. You're measuring from the surface down to something. You're not measuring side to side like you can to get the horizontal location. So you've taken away one of the really important geometric variables. So it's going to be interesting to see how firms deal with populating that depth component and how it's going to be used, and can we come up with something similar to a quality level for the vertical component rather than horizontally only, which, if you look at that, I would hate to see a quality level B horizontally and a quality level C vertically, or you might have quality level C horizontally and quality level B vertically, or something, or even A if you do an invert. And now all of a sudden you've got too much information to really visualize it and deal with it. So it has to be simple. And I'm just not sure how we're going to do that yet. There's a lot of people thinking about that right now. There's problems with everybody's train of thought. There's no perfect solution yet. But maybe we'll come up with one that's acceptable.
Well, to me, it sounds like a whole lot of potholing to bring it to QLA, which is the only one that incorporates a Z currently, right?
Yeah, and we can do that now, but that's expensive and disruptive, and you don't always need it everywhere. You shouldn't only have to dig a test hole where, in fact, there's a potential conflict. But now with ORD, we have to populate the Z even if there isn't a conflict, and then if there's a conflict in the future, then you don't know where did that Z come from. So
and I wonder, do you think that has something to do with manufacturers including the words depth in all of their equipment that they sell?
No, there was a time when I was adamantly opposed to furnishing depth with geophysics or any other method other than I exposed it and I measured it. But I'm over that. And I'm confident that if I put a depth on it and I can annotate where that depth came from in a utility report or with some sort of attribution to a line or metadata, I'm happy enough with that result. So if I just tell somebody, this is where it came from, and it was really good information, or this is where it came from, I'm going to say it came from pipe and cable locator, but it wasn't a great signal.
Right.
But
Yeah.
it's the best I've got, other than a wild guess. So I'm going to tell you that. If I can do that, I'm in good shape. The problem has always been, how do you record enough of that and stay efficient? And how do you make sure that your field people are doing what you want them to do, as the person stamping that work? And with programs like Point Man and other Bluetooth capabilities where you can say, this is where I'm at, this is what I'm recording, and I'm making a note about that, and it's going to attach to this spot and this utility. I think we have. I think we've overcome that, and now it's only the glitches in losing conductivity, or you work all day and you say, oh goodness, that I didn't have that turned on, or something. But we have those kind of lapses in other things too.
Yeah, so I'd like to pick your brain even offline about that with the optimal ranging spar. That's what they were doing with their confidence indication I mentioned earlier.
I worked with Jim Waite a long time on that stuff.
The VLOC Pro 3 RTK is doing something very similar, if not the same. And it's capturing the confidence of the reading as you go, which is also tied to the metadata, which is tied to your actual margin of error for your RTK.
And a little bit of geometry.
Right.
And I really think that is where AI could be very helpful in the future, in my realm of subsurface utility engineering, is looking at all of that data, looking at trends, looking at aberrations, looking at things that don't fit the pattern, and popping them out for review. Right now, it's kind of you got to kind of track it with your head and what you see. But I think the computer could do a good job with that if we train it well.
Nice. I'm going to put this out there too. The Gemini drone Optimal Ranging is working on currently. It's essentially a flying spar. I have an idea to mount it to a robot dog and see what it can do.
Sure.
Potentially could be solving that problem as well.
And Texas A&M, Texas Transportation Institute of Texas A&M, Cesar Quiroga, and some others are working on research projects using that kind of stuff right now.
Awesome.
And they're getting pretty good results. So you should go talk to them.
Yeah, that sounds very cool. Yeah, I would like to see that someday.
Yeah.
So, if not tomorrow. A little personal one. So what's something you're willing to share that nobody knows about you, especially in our industry? The man behind the curtain.
I like to golf, but I don't have enough time. I'm getting old, so I don't have enough time. I like to ride horses, but I don't like to ride on the beaten path. I like to take them out off path.
Off-road horse.
Off-road, off path, out where I shouldn't be by myself. But that's what I like.
That sounds like a lot of fun. Going for the adventure.
Going for the adventure.
Blazing your own trail like you've done in the industry so far.
Well, that's where you're going to find the interesting stuff.
It's more fun
where
out
somebody
there.
else hasn't been.
Yeah. A couple things in closing. So, what advice do you have for younger people? There's a lot of folks here that are younger. There's a next generation coming in. What advice do you have for these folks that you wish you could tell a younger you?
Keep moving forward. Doesn't have to be in a straight line. Probably won't be in a straight line. But don't get discouraged. Just keep moving and you'll get somewhere.
I love that. So finally, where can people find out more about you if you would like them to contact you? How can people reach out?
I'm not much of a social media guy. I do occasionally look at LinkedIn, but I may miss a lot of stuff on it because I can spend about 3 minutes on it, and then I've had my fill of it for quite a few days.
So TikTok's better for you?
I don't think I've ever used TikTok. I've never used Facebook. Email is still probably the preferred way to get to me. and I must have, I bet you 4 or 5 or 6 email addresses out there, but I try to combine them all into one master calendar email, which would be jim@jhanspach, jhanspach.com. And I usually do get around to looking at my email a lot more regularly than LinkedIn.
Sounds good. Well, hey, Jim, again, really great to sit down with you. It's been a while since, I think, pre-COVID, maybe in a conference in Tampa, since we last actually said hi to each other face to face.
Could have
so
been.
Really good to sit down with you.
Thanks.
To pick your brain
well, I
on
was
stuff.
glad to be here, and as I say nowadays, glad to be anywhere.
Right, exactly. So thanks again, Jim.
Sure. Thank you,
Appreciate it.
Adam.